Send a plain Python request to a Best Buy category page and check 3 things: the status, whether the words "choose a country" are in the HTML, and whether a single product is. You get 200 true and false, a country wall you can see, and a catalog you can't. Every other target in this series folded to fewer knobs, a single parameter, sometimes 0. Best Buy is the one that needs the whole toolbox. Wall 1 is the country gate. Visit with a fresh IP and no cookies. And Best Buy doesn't show you the store. It shows you a splash screen. Hello. Choose a country. Canada or the United States. And it doesn't matter which page you asked for. Product, category, homepage, you land here first every time until you click. Get past that and wall 2 is waiting. The catalog is 100% JavaScript. None of the product data is in the initial HTML, so plain requests come back empty no matter how clean the gate pass was. And even a full headless render only gets you wall 3, lazy loading. Products arrive in waves as you scroll. Load the page and stop, and you see exactly one card with gray skeleton placeholders where the other 17 should be. So we bring everything. One scrape do call, and we stack the parameters. Super true for residential IPs. Render true for a real headless browser. Geocode US, so the request originates stateside. Then the clever one. Set cookies, carrying a destination zip and a store ID. That cookie tells Best Buy. We already picked a US store, so the country splash simply never appears. We skip the click instead of scripting it. Block resources false so nothing gets stripped, and a custom wait of 5 seconds to let the first product settle. Super for the IP, render for the JavaScript, geocode for the country, cookies for the gate, 4 walls, 4 knobs, and we're not done yet. Run it. 1 product found. The gate is open, rendering works, and we're seeing exactly what a human sees before they scroll. A single card. That's not the goal, but it's proof the whole pipeline is sound. Now we make it scroll. The parser is straightforward, with one trap. Every product is a list item with class product list item, but so are the half-rendered skeletons. So guard number 1. If the card still carries a skeleton placeholder class, skip it, or your CSV fills with blank rows. Brand and title come from the product title element, image and price from their own test ID attributes, and the SKU isn't in a span at all. It's the data test ID on the list item itself. Now, the centerpiece. Custom Wait bought us 1 product. To get all of them, we script the remote browser itself with a parameter called play with browser. It takes a list of actions that run inside ScrapeDo's headless browser. No Selenium on your machine, no local Chrome. Action 1, wait for a real price element to appear. Proof the grid started rendering. Action 2, scroll in 400 pixel steps. And, this is the important part, reread the page height on every pass. So the scroll follows the page as new products push the bottom further down. Action 3, pause for the last batch. Action 4, guard number 2, don't guess a wait time. Pull in a loop until every skeleton placeholder is gone. That pull is the difference between 1 product and 18. Action 5, a final buffer. That action list is just JSON. We URL encode it into a single parameter and drop it into the request alongside everything else. Wait until load holds the response until the page settles. A timeout of 120,000 milliseconds fails loud after 2 minutes instead of hanging forever. Count them up. That's 8 parameters in 1 GET request. The entire ScrapeDo toolkit aimed at the single hardest page on the site. Run it again. 20 list items found, 18 valid products parsed. 1 card became 18. And the scroll script did in the cloud exactly what you'd otherwise babysit in a local Selenium window. Write it to CSV and open it up. Brand, title, image, price, model, SKU, a pre-owned iPhone 11 at $249.99, a Galaxy A16 at $142.49, a Galaxy S25 Ultra at $1309.99, an iPhone 15 at $644.99. One row per phone, ready to diff against tomorrow's prices. But scroll down and look at the OnePlus 13 row. The price cell is empty. This is the honest failure mode of a page this heavy. The request came back 200, the parser ran clean, but the render finished short and the price never arrived. The request succeeded, the data didn't. On a page this interaction sensitive, some responses always come back incomplete. And a production scraper has to expect that. So we wrap the whole thing in retry logic. Pull the page fetch into a function, then loop, request the page, count the products, and check that titles and prices are actually present. Guard number 3, a full Best Buy page holds around 18 or more products. Fewer than that means a short render. So we retry, up to 4 times before giving up. And because the validity check requires a price, that empty OnePlus row counts as a miss and triggers a retry all on its own. Pagination is the last piece, and it's refreshingly plain. No product counts, no cursor tokens. Best Buy paginates on the CP query parameter. CP equals 1, 2, 3, and so on. We loop incrementing CP until a page comes back empty even after all 4 retries. That empty page is the natural end of the category. Run the whole thing and watch it work. Page 1, 20 products, valid. Page 2 comes back with 14, not valid. So the retry fires and attempt 2 pulls a full 19. Page after page, each one verified before we move on, until page 16 returns nothing and the loop stops. 318 unlocked phones, every page checked, written to disk. 3 walls, 1 request carrying the whole toolbox. Super, render, geocode, cookies, play with browser, and retries on top. The hardest page on the site, running on a schedule. Full code is on GitHub, and Scrape Do gives you 1,000 free credits to start.